Junior Cycle High Level 2012. This is the SEC June paper 1, question 11, and it's an algebra question involving asking to factorize. So by that we were finding a way in which we can write these expressions, instead of that being in essence an addition, okay, subtraction, but you understand what I mean, of two things, to being a multiplication of two things. So the first one we have here is reasonably straightforward. It's about finding what's a common factor of these two terms. It's a case of sort of finding the highest common factor. Well, the highest common factor here, we can see that 5 and 10, what's the highest factor of 5 and 10? It's 5. And what's the highest factor of x cubed and x squared? Well, it's going to be x squared. So 5x squared is the highest common factor in total that we can take from both those two terms. And so what multiplies by 5x squared to get 5x cubed? Well, it's x. And what do we multiply by 5x squared to get the minus 10x squared? Well, it's going to be minus 2. Since the minus 2 times by 5 gives me minus 10. And that's it fully factorized. We have two terms, 5x squared and separately x minus 2 multiplied together, and as an expression it's the same as these two terms. Moving on to part 2, if we were to analyse this question, we'll see there's nothing for each of these that is common. There's no common factor from sort of looking at just viewing it as it is. What you should instead realise is, and the 4 and the 81 and also the x squared and the y squared should create an alarm bell for you. You should realise this is what we call difference of two squares. Okay, it's subtraction of 2x all squared. Now, where did I get that from? Well, I'm looking at 4x squared. I'm saying, well, what's the square root of that? And then I just square it. So square root of 4 is 2, and the square root of x squared is x. And likewise, for the minus 81 y squared, well, we just leave the minus in there, and we're just going to concentrate on 81 y squared. It's probably one of the few times where you just concentrate on the actual term. You don't think about the sign in front of it. So we have 81 y squared, and what is squared to give me 81y squared? Well, it's square root of 81 is 9, and the square root of y squared is y. So we have 9y all squared being the same as 81y squared. So now that we've understood this difference of two squares, and we've got two squares, literally, we have 2x squared, take away 9y squared, we can then use the rule for difference of two squares. And the rule for difference of two squares, a squared plus minus y, a squared minus b squared is equal to a minus b, a plus b. So in this instance we have 2x minus 9y, 2x plus 9y. Just please note, it doesn't matter which one's positive, which one's negative, but the key thing is what's inside these brackets is 2x minus 9y, 2x plus 9y in my new factorized form. Moving on to question part 3, we have 4 terms and we've got to factorize it. We do this by taking 2 terms at a time. You can take these 2 terms and factorize them, and separately these 2 terms. You could also do other pairings. You could take a squared and the 3a and the minus ab and the minus 3b, or you could take a squared minus 3b and minus ab plus 3a. But here I'm going to stick to, wherever possible, just go with the first two and the last 2. So here, what's the common factor of a squared minus ab? Well, it's a minus b, and for the last 2 terms, common factor is 3. So 3, and inside brackets is a minus b. Oh look, we have 2 brackets that are the same expression, So a minus b itself is a common factor, and that common factor is multiplied by a and by plus 3. And we now have our expression fully factorised.